Mm.
Hi, in this video I'm going to talk about an elegant idea of calculus which I like the most, that is concavity and second derivative. Let us suppose I have function f of x, its derivative be first derivative be f prime of x and the second derivative be f double prime of x. So I'm going to stress upon f double prime of x. What happens when f double prime of x is positive, negative and 0? I'm going to explore this idea in this video. At any given x, all the quantities f of x, f prime of x and f double prime of x are numbers, right? So let's consider an example right away. Let us suppose I have f of 3 is equals 4, f prime of 3 is 1 and f double prime of 3 be positive, right? So let me try and sketch this information. F of 3 comma is 4, so 3 comma 4 is the point on f of x, is going to be a point on the curve, and a tangent line having a slope 1, so 2 comma, so yeah, this is a tangent line having slope 1 and f double prime of 3 is positive. What does this means? So you can think of f double prime as first derivative of f prime of x. So if f double prime of x is positive, f prime of x is increasing. So f prime of x is increasing around x is equals 3. So if you go be if you take a point above 3, slope of the tangent is gonna be more than 1. If you consider a point below 3, then the slope of the tangent is going to be less than 1, right? So what does this tells about the function f of x? So if from left to right, say from less than 3 to above 3, the graph of the function is moving more and more steep. So say it's flat here, it's having the slope of the tangent 1, it's becoming more and more steep. If you consider a point here, the slope of the tangent is less than 1. If you consider a point here, the slope of the tangent is more than 1. So this is going to the shape of f of x, right? Let's consider another example where f of 3 is 4, so let me 3 comma 4 is gonna be a point on f of x. F prime of 3 is minus 1, so let me draw this curve. So this is going to be the tangent to the curve at x is equals to 3, and f double prime of 3 is positive here again as in the previous example. So f prime of x is increasing around x is equals 3, so it's minus 1. So if you consider a point below x is equals to 3, it's going to be say increasing, right? Minus 1.1 to minus 1, so minus 0.9. So the graph is going to be more steep below x is equals to 3. Below x is equal to 3, the graph is going to be more steep and it's going to be moving towards 0. So it's going to be moving flat, still in the flat when we go above x is equals to 3. So this is going to be the graph of function. This is around x is equals to 3. If you have if you take a look at the previous example and this, where f prime of 3 is positive here and f double prime of 3 is positive, and here also f double prime of 3 is positive, we can draw some conclusions here. In both the cases, the graph of the function is above the tangent line. So, and if you stand at the tangency point, that is where the tangent is drawn to the curve, and look towards the graph, it's going to appear something like this. How much time?
5 minutes 30 seconds.
Okay. So it's going to look like this. Even here, if you stand at the tangency point and look towards the graph, it's going to look like this. From my 7th or 8th standard physics class, this is called as convex shape, and this is called as concave shape, right? And because the graph of the function is above the tangent line, this case is called concave. So if f double prime of x is positive, then the function is said to be concave. This is why I like this idea very much. Look at how beautifully they are named. And let's see another examples, like what happens if f double prime of 3 is negative. Say f of 3 is 4, f prime of 3 is 1, and f double prime of 3 is negative. So let me plot the graph here. 3 comma 4 and 1. So this is going to be the tangent line to the graph at x is equal to 3. F double prime of 3 is negative. So f prime of x is decreasing around x is equal to 3. So the slopes are say 1.05, 1.9. As we move, so what does it tells about f of x? So the graph is gonna be more steep here, more steep when x is less than 3. So and going to be flat when x is greater than 3. So this is how the graph of the function looks like. So if you draw a tangent here, it is more steeper than this tangent. If you draw a tangent here, it is less steep or flatter than this tangent, right? So let's look at another example where 3 comma 4 is going to be a point on f of x, and the tangent is having a slope minus 1,
8.
right? So here f double prime of 3 is negative, so the slope of the tangents are reducing. So here, so minus 0.9, minus 1, minus 1.1. So when x is greater than 3, the tangents are more steep, and x is less than 3, tangents are less steep. So the graph is going to look something like this, right? In both these cases where f double prime of 3 is negative, the graph of the function is below the tangent line, and when you look at the tangency point towards the curve in both these cases, and look at the stand at the tangency point and look towards the graph, it looks concave and the graph is below the tangent point, so it is called concave down, right? And let's look at the last case where f double prime of x is 0. So let me plot 3 comma 4, f prime of 3 is 1, right? So because f double prime of 3 is 0, so f prime of x is some constant around x is equal to 3. So but f prime of 3 is 1, so f prime of x is 1 around x is equal to 3, and it passes f of x is gonna be something like x 1x plus c, but at x is equal to 4, so it's equals to 1x plus c, x is equal to 3, so c is gonna be 1, So f of x is gonna be a straight line having slope x plus 1. This is the so this line is going to be the curve where there is no concavity. That's all. I am Manas Kalyan and thank you.